Hello, I have with me today Professor Sho Shirakashi from Kindai University in Japan. And Sho and I will be talking about the special issue of International Journal for Parasitology on fish parasites, as well as about the International Symposium of Fish Parasites. Hello, Sho, how are you going?
Hi, good. How are you?
I'm really well. So you have published a paper in the most recent volume of IJP, which we will be talking about a bit later today. And this particular volume was supposed to coincide with the ISFP conference in Cairns, which unfortunately we had to postpone to next year because of COVID-19. But that wouldn't be your first conference. You have been to quite a few ISFP conferences before. Maybe you have some favorite memories or pictures you would like to share?
Sure. My first ISFP conference is in South Africa, 2003. Let me show you some picture from the time. This is Bloemfontein, South Africa. This is my first.
Wow. So it's you, and who is the other person in the picture?
That's Dr. Yoshinaga from University of Tokyo. He was also the representative of the ISFP in Japan. And yeah, this was my first international symposium for the fish parasite, of course. And I was quite nervous. I was a PhD student.
You don't look nervous. You look very confident on the
in here, but it was great experience that, I saw lots of, this is a Nathan Bott from Australia, you can see.
Yeah.
Yeah, Andy Sheen. Yeah, Mark Freeman, Professor Ogawa.
Yeah.
These people I knew from the papers only, and this is my first time I meet them in person, and that's great experience. And talking about the fish parasite.
Yeah, and you look really happy. You all look really happy, but you particularly look very happy.
Yeah, with a can of beer, sure, it's very happy time.
So it was great for networking, wasn't it?
Yes, it was excellent networking, with meeting with those people like in person. Yeah, having the beer over the tables and this conversation. That was like excellent time.
And quite exotic as well. Was it your first time in South Africa?
Yes, see, you can see the giraffes picking up us, on the back. That's quite fun, yeah.
Yeah.
And we stayed in this like a student dormitory. Sharing the room with other students, and that was also fun. Barbecuing with, I think this is Ian Whittington in here and behind. Yeah, and it's the first time I talked to him about the monogenia, and that was excellent conversation.
Yeah.
And also, it's good to see that those big names are like enjoying the party, drinking, and yeah, Kurt Bookman and Professor Ogawa maybe have some kind of serious talk about the monogenia here.
I thought we had a serious talk about beer.
Yeah, well, this is really that's how I really interested into the fish parasites even more by participating in this ISFP conference. And since then, I've been to all the ISFP, I think, in Viterbo, Valencia, and also in Pina del Mar in Chile. Yeah. So this is the next one will be my 5th ISFP conference.
Wow, so something to celebrate, I guess.
Yeah, I think so. Hopefully it's going to happen next year.
Yeah, we are also hoping it to happen next year, and hopefully you'll come and give your invited presentation.
Yeah, that'd be great.
So you were very lucky because I've been on to 3 of the ISFP conferences, the one in Italy, Chile, and Spain. And they were all really well organized, and we have big boots to fill with Tom Carib to organize as excellent conference as the previous ones. So your paper you published in the IJP, in the last issue of IJP, focuses on in vitro culture of parasites?
Yes, the tuna blood flukes, Cardicella orientalis. Yeah, this is a big issue in Japanese tuna farming industry. Yeah, I think we have the same issue in Australia.
Yeah, and you have participated in Australian research as well, so you know firsthand the Australian situation because you've been here sampling yourself.
Yes, this is how I get the job, my job in Kindai University. This is a university that studied the tuna aquaculture,
I
and
see.
first time in the world. And then as soon as they start culturing juvenile tuna, they have a high mortality without any reason. And they first time they didn't know the reason for the mortality, and then they checked the gill, found lots of eggs, and they thought this can be some kind of parasitological disease. This is how I get called up by Professor Ogawa, and then the University of Kindai University is looking for somebody who can work on the fish parasite, and then I started my tuna parasite research here for I think about 10 years now. And now, it's been quite challenging. First, we didn't know anything about this parasite. We don't even have the names.
Yeah.
But we found them 2 or 3 species in the fish, and then try to develop the drug therapy. And then, of course, we have to look for the life cycle, and then we find the intermediate host. Yeah, so that's how now, after about 5 years of research, we elucidated the life cycle of this parasite. And then now I'm looking at more about the biology of this parasite in intermediate host, the polychaete.
So you said that you worked on finding a chemical treatment, which you have published some papers on as well. And because of your research, the industry in Japan and also the industry in Australia is using praziquantel. But how do you think the knowledge of life cycle and intermediate host can help managing the infections on the farm?
Yes. Now my challenging is to use less medication as possible. Now it's just food safety issue, and also for the just appealing for the consumers. People like to have a sustainable aquaculture, and they like to have the fish which is clean and drug safe. So the 3 years ago, I think we did a monitoring of this intermediate host, where they live around the tuna cage culture, and we found particular location that the infected the polychaete lives. And then we eliminate them, and after that, for the last 2 or 3 years, the industry didn't have any blood flukes from that.
That's a fantastic result. But how did you eliminate them? They are quite small. You can't just go and pick them by hand.
Yeah, but they live on the ropes. Yeah.
Oh, on the
so
rope.
It's quite easy on the ropes of the cages. So it's quite easy to clean the ropes once a year.
I see.
And just to get rid of I think it takes about 1 year to develop to the decent size. So just once a year cleaning should eliminate them and stop the life cycle.
Just removing biofouling from the underwater structures once a year was sufficient to eliminate blood flukes on a farm.
It seems so for last 2-3 years. Yeah.
Wow, that's a fantastic result. That's a really great. And how were you proposing to use the in vitro testing or observation? Is it also part of management on farm, or is it to try to find more about biology of the blood flukes?
It's more about the biology, but also we want to know how long will it take for this sporocyst to develop to the within the polychaete. When the cyclia released from the polychaete, and also those kind of things. We have no idea about that. So that's how we want to keep the system in a laboratory with the infected polychaete, and we also try to have the experimental infection to the fish using this system. That's my next step. Next goal.
So you will be using tuna, which are quite small size, like from hatcheries, so, because obviously, if you have like tuna 20 kilo in size, you can't use them in a laboratory infections.
Yeah, I'm also thinking about using mackerel instead of tuna, like surrogate fish host.
Oh,
So
I
it's much
see.
easier to handle and easy to keep in a tank. So so just try to use different fish to infect the have the life cycle in a laboratory. That's my idea.
That will be really interesting because so you don't think that Cardicola orientalis is host specific? You think it can infect other species as well?
That's one thing is that in here, just in my place here, Shirahama, there's no wild tuna. But when we start farming tuna in this bay, the fish become infected. And there's no wild tuna around this bay. So there must be some other fish that bring in this parasite.
And have you tried to do surveys of wild fish species, different wild fish species, or you haven't had opportunity to do this yet?
Wild fish, we haven't had chance yet.
Well, this is really fascinating, and I have to say that I am really impressed by all your impact on tuna blood flux research, not only in Japan but also in Australia, because obviously you really influenced what we are doing here as well. And that's really fantastic. I think you also do research in managing other fish parasites, not only blood flux in tuna. So can you tell us more about those?
Yes, my research subject is now blood flux, monogenia, and also the microsporidium, and also mixozoans. Yeah, and monogenians, of course, is a major issue in fish farming. And currently, I think hydrogen peroxide is a common treatment method. But whenever I go to the fish farmers and ask them what kind of parasite you have in the fish farm, what you want me to do the research on, they always say skin flux or gill flux. I think the times, labors for the treatment, that's too intensive, and it's cost so much for the industry. But they want to have some kind of prophylactic measure. They want to prevent the infection instead of treating the infection. So now my research is to try to develop some kind of preventive measure against these monogenians. So just looking at the biology of the parasite first, looking at the behavior of the Onchomycetium or larval monogenians, and see if we can use that kind of behavior to control this parasite to infect the fish. That's my challenge now.
So what could you do, for example, like what would be an example of using the behavior of the parasite to control it or to manage it?
Yeah, most of the larval monogenia, the Onchomycetium has a phototoxic behavior. They are attracted to the light. So I shaded the cage. I put the covers on a cage, so the cage is dark, and outside the cage is light. So and using that simple technique, I managed to reduce the infection by maybe about 30%.
Oh wow, that's a really great result. And can it be picked up by on commercial scale? Like can the industry use it?
Yeah, the industry started using a little bit, but then they said they have to remove the shade every time they feed the fish, and this is too much trouble. So they say it's effective to prevent infection, but also still need like they feed the fish maybe 2 or 3 times a day, but every time they have to remove the shade, and that's too much time taking for them. So I have to think a new method, more using light trap. Trap to that's my. I'm still working with some kind of industry to develop a machine to trap this larval monogenians by light, using the light.
Yeah, that sounds fascinating. And you mentioned that you also work on mixosporidians and microsporidians. Also from the point of view of managing the parasites, or is it more from the point of view of taxonomy and biology of the parasites?
No, it's more managing. Like mixozoan now is a huge problem in Japan because kudoa, some kudoa species is causing food poisoning.
Oh no! So you eat the fish and you get like intoxicated because of like you can get toxic.
And you get the diarrhea, vomiting, and we have maybe a few hundred patients per year from the kudoa.
Wow! So, and is it particular fish species, or is it all fish species which can be the source of this poisoning?
it seems to be certain species of the kuroa that cause food poisoning, and particularly in Japan, the flounder, the Kuroa septempunctata infecting olive flounder is a big issue now. And but of course, there's no life cycle is known for any kind of Kuroa species yet. So there's no preventive measure for, and there's no drug for mixozoans. So now I'm trying to work on drug development, also for the finding life cycle of these mixozoan species.
Wow, so this is quite challenging, but obviously you've done similar things in blood flux. So
yeah, but it's most work lottery. Like it takes years, and if you find them, you're happy, but it's it's like lottery. Just you have to, but it's kind of fun. We go to with the students. We go to the field trip, digging sediment, finding all those annelids and stuff like that. It's fun, but it takes time and takes a lot of work. Yeah.
So the flounder which is affected, is it farmed? Like, is it on commercial scale?
It's farmed flounder that can be infected, and that's the problem.
Are they farmed in cages or ponds or tanks?
In land-based tanks.
Land-based tanks.
Yeah.
So maybe treating, would it help if they treated the incoming water to maybe more?
Yeah, we worked on this, and we found that UV treatment, ultraviolet, can disinfect infective stage of kuroa.
Okay.
Not all the pharmacies equipped with a UV because the equipment is expensive.
Yes.
And so, but now they start using it, and in Japan, the kuroa infection in flounder is almost negligible. But still, we have the imported fish coming from other countries that are infected. So you import a live flounder from Korea, and then those are infected with kuroa, and we get the food poisoning.
And is it causing food poisoning only if you eat it as sashimi, or even if you cook the fish, it still causes food poisoning?
It's only when you eat uncooked fish, like sushi and sashimi. Yeah, and the flounder in Japan, flounder has to be like, it's like a fresh fish food. We don't really cook flounder. We usually eat them.
Okay. Yeah, and obviously eating fish as sashimi, that's the best way to eat, I think.
Yeah, for us Japanese, yes.
Yeah, I really enjoyed my visit to Tokyo when you showed me around and took me to all these restaurants with amazing food. And it was just over a year ago, but seems to be such a long time ago. So I really enjoyed all the Japanese food, and yours and Professor Ogawa's hospitality. It was really fantastic.
You seem to enjoy the sake too.
Yeah. Well, you have to have sake if you eat sushi.
Yes.
Of course. Going back to fish parasites, what do you think are the next challenges for Japanese aquaculture? Do you think the same species of parasites will continue being the problem, or do you expect some new species of parasites? And is Japanese aquaculture changing much from the point of view of farming procedures and species, or is it going to stay the same for the foreseeable future?
Yeah, now the Japanese aquaculture is more diverse. We have more species of the fish that we cultured. And just last year, we found a new species of blood skin flukes from the coral trout. It's grouper, type of grouper that's newly developed as a new aquaculture target.
Wow.
And then they have some problem with the skin flukes, and we looked at them, and it's a new species. So it's always emerging. New fish start to be cultured, and the new disease emerging. Yeah.
So
I think even the blood flukes. Pardon me?
Always lots of work for you.
Yeah, always new things, but it's just very hard to keep up with all the new parasites coming in and all the new diseases, and but they always say, we need a treatment right away, but it takes time. Yeah, that's a problem. Yeah.
So this is really fascinating, and we're looking forward to you coming to Cairns to ISFP and giving a presentation about management of parasitic diseases in aquaculture. it's really incredible to see all the developments in Japanese aquaculture, because the species are quite different than the fish species farmed in other countries. So you don't really have Atlantic salmon and sea lice as the main problem. You have lots of different species and lots of different parasites. And it's amazing to see how you still manage to do a research to address all these issues. So thank you very much for your time. I really appreciate it. And congratulations on your publication in IJP. And I really hope to see you at ISFP in July next year. Thank you.
Yes, thank you very much. See you soon.